Anticipated 35% growth in manufacturing, defense, and agriculture sectors by 2026. Competitive forecasts in the US and China amidst international robotics advancements. Overview. The manufacturing, defense, and agriculture sectors in the US and China are poised for significant growth, with projections indicating a 35% increase by 2026. This growth is largely driven by rapid advancements in robotics technology. A detailed analysis showcases the trends, opportunities, and forecasts that will shape these sectors, particularly underscoring China's prominent role in the global robotics landscape. Key trends and data. In 2023, China outpaced Germany and Japan to become the world's leading nation in industrial robotics, showcasing 470 robots per 10,000 employees. This accounted for a staggering 51% of global robot installations, highlighting China's aggressive push towards automation. The Chinese robotics market was valued at approximately $6.6 billion in 2023, with expectations for continued growth, including annual revenue increases exceeding 20%. Strategic governmental initiatives, such as the Robot Plus Application Action Plan and the 14th Five-Year Plan, are pivotal in fostering the growth of robotics across various industries. These initiatives emphasize automation and aim to enhance China's competitive edge in manufacturing, defense, and agriculture. Use cases in key sectors. 1. Manufacturing. The integration of robotics into the manufacturing sector is significant, particularly in automotive, electronics, and pharmaceuticals. Robotics applications optimize processes such as welding, assembly, and material handling, leading to enhanced efficiency and productivity. 2. Defense. In the U.S., the defense sector is witnessing innovative applications of robotics, focusing on modern warfare and logistics. Robotics is being integrated into unmanned systems surveillance and maintenance, providing strategic advantages. 3. Agriculture. Robotics is revolutionizing agriculture through the development of automated solutions for soil preparation, pest control, planting, and harvesting. These innovations are essential in addressing labor shortages and increasing production efficiency. Investment and innovation landscape. Both nations are heavily investing in robotics to improve productivity and operational efficiency. China's approach is characterized by strong state support and long-term planning, leading to rapid adoption of robotics technology. In contrast, the U.S. relies more on private sector innovation and competition. China's focus on domestic production and self-reliance is reflected in its increasing share of robot patents and significant advancements in smart manufacturing. The U.S. defense sector's emphasis on AI and robotics integration presents a unique pathway for growth, contrasting with China's broad policy framework that aims to establish the country as a global hub for robotics innovation. Historical context and future projections. Early 2000s, China's industrial robotics sector was nascent, heavily reliant on foreign technology. 2015, domestic manufacturers held only 17% of the robotics market. 2020, the Made in China 2025 initiative was launched, aiming to bolster domestic capabilities. 2023, China achieved a robot density of 470 robots per 10,000 employees, marking a significant leap in automation. 2024 and beyond, continued growth is anticipated, driven by targeted policies and investments in various sectors, including healthcare and agriculture. Conclusion. The projected 35% growth in the manufacturing, defense, and agriculture sectors by 2026 is inextricably linked to advancements in robotics technology. China's strategic initiatives and swift adoption of automation technologies position it as a formidable player in the global market. The U.S., while also making strides in these areas, exhibits a different growth trajectory characterized by private sector dynamics. Both countries present lucrative opportunities for foreign stakeholders seeking to invest in the expanding robotics sector, signaling a significant shift in industrial practices propelled by technology. Sources and further reading. 1. China Briefing Insights on the Opportunities Within China's Robotics Industry. 2. International Federation of Robotics Reports on Global Robot Adoption Trends. 3. Government Publications Details on China's strategic initiatives and plans for robotics development. This report illustrates the dynamic landscape of robotics in the US and China, emphasizing the implications for the manufacturing, defense, and agriculture sectors as they navigate evolving technological advancements. The anticipated 35% growth in the manufacturing, defense, and agriculture sectors in the US and China by 2026 is underpinned by significant advancements in robotics technology. A closer examination reveals several counterintuitive insights regarding the current dynamics in these sectors, particularly contrasting the approaches of the US and China. Counterintuitive insights. 1. China's government-driven growth versus US private sector innovation. While one might expect that a capitalist economy like that of the US would lead in robotics due to private sector incentives, the data illustrates that China's growth in robotics is heavily state-supported. This centralized approach allows for rapid implementation of technologies across sectors, while the US relies on fragmented private initiatives that may not coordinate as effectively. The Chinese government's clear long-term planning contrasts sharply with the US model, where innovation can be hindered by regulatory and competitive constraints. 2. China's leading position in robot density. It may seem surprising that China, often seen as a low-cost manufacturing hub, leads the world in robot installations at 470 robots per 10,000 employees. This statistic challenges the perception that lower labor costs would deter automation. Instead, the data suggests that China's focus on automating processes is a strategic move to enhance efficiency and productivity, thereby increasing its global competitiveness. The significant leap from 17% domestic market share in 2015 to 47% in 2023 indicates a rapid maturation of its robotics industry. 3. Investment in robotics despite economic challenges. The expectation might be that economic downturns or global disruptions would slow down investment in technology sectors. However, both the US and China are ramping up investments in robotics amidst global uncertainties. This trend reflects a counterintuitive understanding that companies perceive automation as a necessary adaptation to economic pressures rather than a luxury. The growth in the robotics market, projected to exceed $6.6 billion in China, underscores the resilience and strategic foresight of investments in automation technologies. 4. Diverse applications across sectors. One might assume that robotics would be primarily confined to high-tech industries like manufacturing and defense. However, the counterintuitive trend is that robotics is making significant inroads into agriculture and healthcare as well. In agriculture, robots are being developed for tasks traditionally considered labor-intensive, such as pest control and soil preparation. This challenges the notion that automation is only for high-skilled labor, showcasing a broader application of robotics across various sectors. 5. The role of education in robotics integration. It may be unexpected that educational institutions are becoming a focal point for robotics integration. The anticipated expansion of robotics into the education sector, particularly in vocational training, signifies a shift in how robotics is perceived, not merely as a tool for industry but as a critical component of future workforce development. This reflects a forward-thinking approach that recognizes the importance of skill development in tandem with technological advancement. 6. Global patent dominance by China. The notion that innovation is primarily driven by established players in the US and Europe is challenged by China's leading role in robotics patents. With over 190,000 effective robot-related patents, China accounts for about two-thirds of the global total. This dominance in intellectual property signifies a robust innovation ecosystem, contradicting the expectation that innovation is solely the domain of Western countries. 7. Focus on smart manufacturing. While one might expect that traditional manufacturing processes would resist change, the evidence indicates a strong pivot towards smart manufacturing in China. This transition is not merely about replacing labor with machines, rather, it involves integrating advanced technologies like AI and IoT into manufacturing processes. This nuanced understanding reveals that the future of manufacturing is not just automated but intelligently connected, enhancing operational efficiencies in ways previously unimagined. 8. Investment opportunities in a competitive landscape. The assumption that competition in the robotics sector would stifle collaboration is overturned by the burgeoning opportunities for foreign stakeholders in both the US and China. The strategic initiatives outlined in China's Robot Plus Application Action Plan show a distinct openness to foreign investment and collaboration. This creates a unique landscape where competitive nations can simultaneously foster partnerships, challenging the notion that collaboration is limited to less competitive environments. In conclusion, the anticipated growth in the manufacturing, defense, and agriculture sectors in the US and China by 2026, driven by advancements in robotics, reveals several counterintuitive trends that defy conventional expectations. These insights demonstrate a complex interplay of government policies, market dynamics, and technological integration that will shape the future of these critical sectors. The report discusses the anticipated 35% growth in the manufacturing, defense, and agriculture sectors in both the US and China by 2026, driven largely by advancements in robotics technology. While the broad strokes of this report may be grasped by many readers, several nuanced and significant details are likely to be overlooked. Here are some of those key points along with explanations of their significance. 1. China's dominance in industrial robotics. One of the most striking figures is that China has surpassed Germany and Japan, achieving a density of 470 robots per 10,000 employees in 2023. This statistic is not merely a number, it reflects a significant shift in global manufacturing power dynamics. The fact that China accounts for 51% of global robot installations is crucial, as it indicates not only the scale of its robotics industry but also its strategic focus on automation as a driver of economic growth. Significance: this dominance suggests that China is not just participating in the global robotics market, it is setting the pace. This has implications for supply chains, global competitiveness, and international trade. Countries looking to maintain relevance in manufacturing and related sectors must consider China's advancements seriously, as they may dictate market trends and technological standards. 2. Government policies as catalysts for growth. China's growth in robotics can be attributed to specific government initiatives, such as the Robot Plus Application Action Plan and the 14th Five-Year Plan. These policies create a structured environment for innovation and investment in robotics, illustrating a clear state-driven approach to advancing technology. Significance: the proactive support from the government contrasts sharply with the more fragmented innovation landscape in the US, which is largely driven by private sector initiatives. This difference in approach could lead to a widening technological gap between the two nations, as the state-led model allows for long-term planning and resource allocation that private sectors may struggle to achieve. 3. Integration across various sectors. The report highlights the integration of robotics into critical sectors such as manufacturing, agriculture, and defense. For example, in agriculture, robots are being developed for essential tasks like soil preparation and pest control. This cross-sector integration is vital, as it showcases the versatility of robotics in addressing different challenges across industries. Significance: the ability of robotics to enhance productivity in diverse sectors signifies a fundamental shift in how industries operate. Automation can lead to increased efficiency, reduced labor costs, and improved safety in hazardous environments. Stakeholders in various industries should recognize that robotics is not confined to manufacturing alone but is a transformative technology that can redefine operational standards across the board. 4. Intellectual property and innovation.
China's rapid increase in domestic robot patents, which accounted for about 2/3 of the global total by mid-2024, underscores the importance of intellectual property in fostering innovation within the robotics sector. This transition from reliance on foreign technology to developing homegrown innovations marks a pivotal moment for China's manufacturing capabilities. Significance: the emphasis on intellectual property signifies a shift towards self-reliance and technological sovereignty. For foreign investors and companies, understanding this landscape is crucial as it may influence collaboration strategies, competitive positioning, and market entry tactics. Additionally, this trend may lead to increased scrutiny of foreign technologies and partnerships, requiring companies to adapt their strategies accordingly. 5. Differentiation in growth strategies. While both China and the US are set to experience growth, the report points out that their strategies differ markedly. China's growth is heavily state-supported, while the US relies on private sector innovation. This difference reveals underlying economic philosophies that could shape the future landscape of the robotics industry. Significance: the contrasting strategies imply that companies and investors need to tailor their approaches based on the regulatory and market environments of each country. For instance, foreign companies looking to enter the Chinese market may have to navigate state policies and align with local initiatives, while those in the US might focus on fostering innovation through partnerships and competition without as much government intervention. 6. Regional development initiatives. The report mentions various regional initiatives in China aimed at bolstering the robotics industry, such as the development plans in Chongqing and Hangzhou. These localized strategies highlight a broader trend of regional governments taking the initiative to cultivate specific sectors within their jurisdictions. Significance: this regional focus indicates that opportunities may not be uniformly distributed across the country. Investors and businesses should consider regional strengths and policies when entering the Chinese market. Understanding local government priorities can lead to strategic partnerships and investment opportunities that align with regional development goals. 7. Educational integration of robotics. The report notes the expected expansion of robotics applications into education, particularly in integrating advanced technologies such as AI and big data. This suggests a forward-thinking approach to workforce development, preparing future generations for jobs in a highly automated economy. Significance: as education systems adapt to include robotics and automation, this can lead to a more skilled labor force capable of navigating the complexities of modern technologies. For businesses, engaging with educational institutions could provide a pathway to influence curricula, ensuring that the next generation of workers is equipped with the necessary skills to thrive in an automated world. 8. Focus on sustainability and ethical considerations. The report touches on the importance of developing ethical frameworks for robotics, which is a crucial aspect that may be overlooked. As robotics technologies advance, the implications for labor markets, privacy, and ethical use of AI become increasingly significant. Significance: addressing ethical considerations is essential for the responsible development of robotics. Companies and governments must navigate the balance between innovation and ethical use to foster public trust and acceptance of robotic technologies. This perspective not only shapes regulatory policies but also influences consumer behavior and market dynamics. Conclusion: the anticipated growth in the manufacturing, defense, and agriculture sectors in the US and China, fueled by advancements in robotics, presents numerous opportunities and challenges. While the overarching trends may capture the attention of many, the details surrounding government policies, regional strategies, intellectual property, and ethical considerations are equally important. Recognizing these nuances can provide stakeholders with a comprehensive understanding of the landscape, enabling them to make more informed decisions in this rapidly evolving market. 1. China's dominance in robotics. China has rapidly ascended to become the global leader in industrial robotics, with 470 robots per 10,000 employees as of 2023.
This surpasses Germany and Japan, underscoring China's aggressive push for automation through strategic government initiatives like the Robot Plus Application Action Plan and the 14th Five-Year Plan. The country's robotics market, valued at $6.6 billion in 2023, is projected to continue growing at an annual rate exceeding 20%. Illustrating the success of national policies and the emphasis on enhancing domestic capabilities. 2. Sector-specific applications. Significant advancements in robotics are transforming key sectors such as manufacturing and agriculture. In manufacturing, robotics are being utilized for processes like welding, handling, and assembly, particularly in industries such as automotive, electronics, and pharmaceuticals. In agriculture, robotics are being developed for tasks including soil preparation, pest control, and harvesting. These integrations not only enhance productivity but also signify a broader shift toward automated solutions in traditional sectors. 3. Investment opportunities and policy support. Both the US and China are investing heavily in robotics to enhance productivity. But their approaches differ. China's state-supported growth model contrasts with the US's reliance on private sector innovation. The Chinese government actively encourages foreign investment through policies and initiatives that aim to create a conducive environment for international stakeholders. This includes incentives for investment in robotics across various sectors including manufacturing, healthcare, and agriculture, highlighting the lucrative opportunities available for foreign investors in a rapidly evolving landscape. 4. Future pathways and competitive strategies. The anticipated 35% growth in the manufacturing, defense, and agriculture sectors by 2026 is closely tied to ongoing advancements in robotics. While China's comprehensive state-driven approach may lead to rapid advancements in market share gains, the US may rely on private sector innovation and competition to drive growth. The contrasting strategies of both nations present unique challenges and opportunities for global stakeholders. Emphasizing the importance of understanding the competitive dynamics as these sectors evolve in the context of international robotics advancements. 1. The Industrial Revolution. 18th to 19th century. The Industrial Revolution marked a significant turning point in history, transitioning economies from agrarian-based to industrial-based systems. This period saw the introduction of machinery and technology that revolutionized manufacturing processes such as the steam engine and mechanized looms. The growth of factories and mass production transformed not only the manufacturing sector but also led to urbanization and changes in labor dynamics. The introduction of mechanization in agriculture, including the seed drill and mechanical reaper, significantly increased agricultural productivity. Similar to the current advancements in robotics, the Industrial Revolution led to a massive transformation in productivity and efficiency across multiple sectors, fostering economic growth and innovation. 2. The Space Race. 1957 to 1975. The space race was a competition between the United States and the Soviet Union during the Cold War, primarily focused on space exploration and technological supremacy. The launch of Sputnik 1 by the Soviet Union in 1957 ignited a series of technological advancements including satellite technology, computer technology, and robotics, particularly in the context of space exploration. This period saw significant government investment in research and development, leading to innovations that have had lasting impacts on various industries. The advancements in robotics, particularly in the context of space exploration like robotic arms on space shuttles and rovers on Mars, illustrate how competitive pressures can drive technological progress, akin to how the US and China are leveraging robotics technologies today in manufacturing and defense sectors. 3. The Digital Revolution. Late 20th century. The digital revolution, which began in the late 20th century, was characterized by the shift from analog and mechanical devices to digital technology. The rise of computers, the internet, and information technology transformed industries, enabling automation and more efficient processes in manufacturing, services, and communications. Just as robotics is anticipated to reshape manufacturing, defense, and agriculture, the digital revolution fundamentally changed how businesses operate and deliver value. Companies began leveraging technologies like computer-aided design (CAD) and automated production lines to enhance productivity and reduce costs, paralleling today's trends in robotics and automation. The anticipated 35% growth in the manufacturing, defense, and agriculture sectors in the US and China by 2026 is poised to reshape the landscape of these industries, primarily driven by advancements in robotics technology. The following predictions outline the future outlook for these sectors, considering the competitive dynamics between the two nations and the role of robotics. 1. Surge in robotics adoption. By 2026, both the US and China will significantly increase their adoption of robotics across various sectors. China, already leading with 470 robots per 10,000 employees as of 2023, will continue to dominate in terms of sheer volume and innovation. The US, while lagging in robot density, is expected to leverage its strong private sector to catch up through innovative applications of robotics, particularly in defense and specialized manufacturing. 2. Enhanced manufacturing capabilities. The manufacturing sector will see a transformation due to robotics integration, streamlining production processes and enhancing efficiency. In China, the emphasis on smart manufacturing supported by government policies will enable factories to achieve higher levels of automation. In the US, advancements in precision robotics and AI will facilitate more flexible manufacturing systems, catering to customized production needs and reducing lead times. 3. Revolutionizing agriculture. The agricultural sector will undergo a significant makeover as robotics become essential in farming operations. In China, robotic solutions for tasks such as soil preparation, pest control, and harvesting will enhance productivity and sustainability. The U.S. agriculture sector will similarly adopt robotics, focusing on precision agriculture techniques to optimize resource usage and improve crop yields, particularly in the context of climate change challenges. 4. Defense innovations and robotics integration. The defense sector will be a primary driver of robotics growth in the U.S. With increasing investments in AI and robotics systems for logistics, surveillance, and combat applications, the U.S. is set to enhance its military capabilities. Conversely, China's defense strategy will focus on integrating robotics into its military operations, emphasizing unmanned vehicles and automated systems to achieve strategic advantages. 5. Collaboration and competition in R&D. Both nations will ramp up their research and development in robotics, leading to innovations that may redefine industry standards. In China, state-supported initiatives will foster partnerships between tech companies and academia, focusing on cutting-edge technologies such as AI and machine learning. The U.S. will rely on private sector initiatives, encouraging startups and established companies to innovate rapidly and compete on a global scale. 6. Job market transformation. While robotics will enhance productivity, it will also transform the job market in both countries. The demand for skilled labor in robotics design, maintenance, and operations will surge. In the US, there will be a focus on upskilling the workforce to adapt to new technologies, while China will likely see a shift in labor dynamics as agricultural and manufacturing jobs become increasingly automated. 7. Regulatory frameworks and ethical considerations. As robotics become more prevalent, both nations will need to establish comprehensive regulatory frameworks addressing ethical considerations, safety standards, and employment impacts. The U.S. may adopt a more decentralized approach, relying on industry standards, while China will likely implement a top-down regulatory structure to ensure compliance with its strategic goals. 8. Global investment trends. The global robotics market will attract significant foreign investment, particularly in sectors like manufacturing and agriculture. China's favorable policies for foreign stakeholders will lead to an influx of investments, while U.S. firms will seek international collaborations to enhance their robotics capabilities. The competition for global market share will intensify, with both countries aiming to establish themselves as leaders in robotics innovation. Conclusion. The future outlook for the manufacturing, defense, and agriculture sectors in the US and China is characterized by a substantial shift towards automation driven by robotics advancements. By 2026, the anticipated growth of 35% in these sectors will reflect the ongoing competition and collaboration between the two nations, ultimately reshaping the global landscape of industry. The integration of robotics promises to enhance productivity, transform job markets, and necessitate new regulatory frameworks, highlighting the profound impact of technology on the future of work and industry.